orders in lifetime, number of visits per user if you want to calculate such things. And how it works, like from the figure itself, it is appearing here. So it is exponential kind of change in the line plot. Now, this is what you can see here. 1 unit increase in x multiplies y by e to the power raised by alpha. Now, how to perform multiple regression analysis? Define the problem, choose the model, interpret the results, or for example, define the problem, then go for collection of data, prepare the data, then choose the model, estimate coefficients, assess model fit, then interpret the results. Go for validation and report the findings after concluding the results. Now, it comes to least square method. This is a form of mathematical regression analysis used to determine the line of best fit for a set of data, providing a visual demonstration of the relationship between the data points, which you can see here. Now, it refers to the least squares refers to the square of the vertical distance between the points and the lines. Now, this form of mathematical regression analysis is used to determine the line which could best fit. And these are the distributed data, but this is the line which best fit here. So, least squares refers to the square of the vertical distance between the points and the line. So these are the lines and these are the squares. So this is how you can go for least square analysis, and for this purpose you need to see the box or square and the lines where the data are falling. Now, how the least squares method works. So basically, in understanding the concept of least square, you need to understand where and how this least square approach will fit and help to achieve the goal in data analysis and interpretation. So you need to understand the steps involved in the least square methods. Then what are the advantages of this particular method? Then compare the predicted outcome by using some similar methods, different similar methods, to evaluate the predicted values or data. Now, these are the 5 steps which you need to be aware while you are performing the least square analysis or implementation. What is the least square method? How does it work? What are the applications of the least square method? And what are the limitations of the least square method? What are the alternatives to achieve the similar goal which can be achieved by least square methods? Now, how to interpret the model when you are implementing so many different methods in machine learning or artificial intelligence. Then you need to also be aware of interpretation. For example, interpretation of the coefficients. In a multiple linear regression, the regression coefficients are the change in the response variable with the unit change in corresponding explanatory variable, keeping all the other explanatory variables constant. That is partial slopes. For logistic regression, interpretation is similar, except for the fact that the change is not linear, but in terms of log of odds. Here, a unit change in explanatory variable brings about a change of beta in the log odds. So if the explanatory variable increases by 1 unit, the odds of pi equal to 1 increases by a factor of 10 raised by beta. So these are some of the things. Now it comes to the goodness of fit. So this is a kind of a statistical test to determine if sample data is accurate or somehow skewed. So this is kind of foreseeable term because every person who is working for any kind of project, they need to be aware and they need to make sure that if my data quality is good, accurate or not. So this goodness of fit is similar to that. So what you need to think is how accurate the sample data is and how accurately you are working and you are predicting the outcome. So it is nothing but you need to evaluate the accuracy. And there are different way of evaluating the goodness of fit. So this is one of the example where you need to understand how much should we invest in public education, for example. How economic question, what is the effect of education on earnings? So this is how an example could be implemented. So goodness of fit is also one of the small term which you need to keep in your mind. Now, this goodness of fit can be understood from this plot also. For example, this line shows goodness of fit. This is overfitting, and this is generalizability. So these are some of the deep analysis and minute evaluation. Now it comes the bootstrap. Bootstrap is a kind of a step in business or in research purpose also, where it refers to the process of using your existing resources to start your business or helps it flourish. It is a free and open source front-end framework for developing responsive and mobile-first websites using HTML, CSS, and JavaScript. So computers execute the programs stored in the main memory, and initially operating system is on the hard disk. When the computer is turned on, it does not have an operating system loaded in the memory, and the hardware alone cannot do the operations of an operating system. To solve this paradox, a special program called Bootstrap Loader is created. So Bootstrap, meaning you can understand from here. Now, the bootstrap can be of different types, which I'm not going to explain, but this you will need it rarely. So this is least common for data analysis, but of course you need to be familiar. So how you can use it, the bootstrap? Is it easy to use? Yes. How is it friendly? How it works in integration? What are the documentation part you need? There are lots of details which you need to know about bootstrap and its applications. Now the pros and cons: easy to use, responsive design, customizability, consistency across browsers, large community and support. Cons: over reliance on classes, learning curve for customization, over reliance on classes. So performance issues are coming, uniformity. Now, there are something called standard errors. This is very common but very easy to analyze, and it is required almost in every step. What is a standard error and what are the standard deviations? These things you need to be aware. So, for example, here a standard error equal to 1 minus r square upon square root of n. where if the value of R is less than the PE, then there is no evidence of correlation. If R is 6 times more than the P, the correlation is certain and significant. By adding submitting P from coefficient of correlation, we can find out the upper and lower limits within which the population coefficients of correlation may be expected to lie. So basically, these are some of the quite basic terms which you need to know it. Like every time you need to be aware about the error bar, standard deviation. So because you will need it in almost every work data analysis. Then it comes to standard error interpretation of regression coefficients, which you can decide, for which you need to know. For example, if you are working for business, then a scale of predictors, sample size, multi-collinearity, residual variance, leverage points. Then it comes to regularizations. So this is required for all kind of machine learning algorithm or artificial intelligence. So here you need to understand the key concepts: overfitting, underfitting, then adding some loss function, reduce the model complexity, then go for some kind of algorithm, some kind of approaches for regularization like lasso, ridge, elastic net, ensembling, neural network, and there are some more things. Then for business application, you need to understand manufacturing, retail, healthcare, where it can be applied. Now, what is regularization? So basically, it is a set of techniques in machine learning that reduce overfitting and improve the model's generalizability. It's a key element of machine learning and is crucial part of CNNs. Regularization helps models identify the most important features in the data set without getting caught up in noise or irrelevant details. So these are some of the things which you need to know about data regularization, and you need to understand where it can be used and how it can be used. So this is something which is kind of making your work more fascinating. If you understand regularization, then the data science model development could be more fascinating and more attractive for those people who understand the data model. Now,